Multi-domain operations is the Army's strategic-level concept for operating as part of a joint force on an increasingly complex and lethal battlefield across 5 contested domains: space, cyberspace, air, maritime, and land. The MDO concept emphasizes the convergence of cross-domain capabilities to prevail in competition, to penetrate standoff capabilities, disintegrate area denial systems, exploit freedom of maneuver, to force the return to competition, and to set conditions for long-term deterrence. Cross-domain maneuver is the tactical application of multi-domain operations within the close area fight, which presents a challenge to integrating cross-domain capabilities due to the reduced time available and limited access to centrally controlled enablers. Speed of action, coordination, and the synchronization of effects place a premium on organic capabilities. At the tactical level, the purpose of soldier lethality is to enable overmatch against threat capabilities. Overmatch is achieved through the synergistic effects of capabilities across multiple domains. Commanders conceptualize capabilities in terms of combat power. Combat power includes leadership and information, as well as the warfighting functions: command and control, movement and maneuver, intelligence, fires, sustainment, and protection. Overmatch is the measurement of combat power and warfighting function capabilities required to dominate the threats. To understand the challenges faced by the multi-domain light infantry platoon in 2028, we will focus on a likely urban mission to illustrate the operational demands, as well as the capabilities, systems, and technologies required to ensure overmatch and maintain the readiness of future close combat platoons. Close combat platoons will operate in a constant state of competition, in which threats and adversaries will utilize various information streams, including social media, false narratives, and cyber attacks, to fracture U.S. alliances, partnerships, and resolve. On this mission, threat forces push narratives that the host nation and the coalition forces are unable or unwilling to provide services to the population. Threat forces seize a power distribution facility on the outskirts of a dense urban area. Once threat action creates a crisis, there is a shift from competition to armed conflict. Friendly forces task ISR assets from space and air to compile data on the threat situation from intelligence systems, to create a 3D representation of the objective area, including the location and disposition of forces, and the capabilities of various weapons systems. AI is used to rapidly analyze and identify likely threat actions. Leaders utilize AI to facilitate control by analyzing and measuring the capabilities and limitations of friendly and threat forces. Each course of action is designed to employ available capabilities from across all domains to pose multiple and compounding dilemmas on a threat. AI aids the evaluation of the war-fighting function capabilities and the scheme of maneuver required to ensure overmatch against the mission demands, while minimizing operational risk, maximizing efficiency, and maintaining overall unit readiness. Once leaders select the best COA, the operational graphics and tasks are disseminated directly to the soldiers' displays and to platoon systems for preparation and mission rehearsals. Command and control systems are used to enable convergence, the rapid and continuous integration of capabilities in all domains within the scheme of maneuver. In the penetration phase, the platoon leverages cross-domain EMS capabilities to infill squads, undetected by threat sensors, to their tactical positions. The platoon employs robotics and autonomous systems for standoff from personnel, systems, and hazardous conditions. This 360-degree protection provides early warning and assists friendly forces with rapid target identification and operational assessments. Friendly forces isolate and disintegrate the threat through the destruction and disruption of the enemy command and control, communication, and intelligence collection capabilities. Employment of offensive electronic warfare, deception operations, and multispectral sensor-fused munitions degrades the ability to conduct operations while leading to a rapid collapse of the enemy's capabilities and will to fight. deception operations, and the introduction of false information in enemy networks will support successful kinetic engagements. While conducting decisive actions, cross-domain synergy enables rapid exploitation, minimizing the operational costs to friendly forces and prevents the enemy from reintegrating its systems and consolidating gains. Enhanced visual devices provide individuals with the ability to conduct rapid target acquisition and maximize the weapon system's lethality under all conditions. Augmented vision also enables soldiers to track friendly movements across the objective and through buildings. Urban operations are high-intensity combat, which can rapidly deplete both manpower and resources. Sensor suites, including physiological status and logistical status, aid in informing leaders on the health status of personnel and expenditure rates of equipment and supplies. This data provides leaders with the information required to assess operational progress and anticipate logistical requests without the need to slow the tempo of the operation, reducing the cognitive demands on both leaders and soldiers. As an initial foothold is seized in the power plant, threat forces use a sub-T corridor in the basement to reposition forces. In-stride sustainment, provided by aerial resupply, is dropped in the tactical support area, then delivered to point of need by organic unmanned logistics systems. Mission essential equipment and critical supplies are recovered by robotics and autonomous system platforms and distributed to forces preparing to enter the corridor complex. This logistics support package includes hazmat sensors, communication relays, and mobile protection systems to aid movement through the sub-T areas. Initial sub-T reconnaissance is conducted through the use of robotics and autonomous systems to map the sub-T corridor complex. Command and control in sub-T conditions is enabled by mesh network communication relays and sensor suites. Hazards and obstacles are detected and squads maneuver based on the information provided. Updates to the threat activities and locations are relayed to the above-ground units to direct maneuver and to seize the threat forces. Following the mission, information